as unshared concrete flyweight, we'll create a paragraph class. This holds a location, for example 1, 2, or 3. It stands for where in the document the paragraph lives. Next to that, a paragraph also holds a set of characters. We add a constructor that accepts these two. Then we implement iCharacter. It's a flyweight, so it should implement this. And this means we have to add a draw method. Drawing a paragraph, in our case, means that we want to ask each character to draw itself. So what we do here is pass through the extrinsic state to the draw method on each character. And that's it already for our paragraph. On to the factory. Our character factory doesn't know how to create this unshared concrete flyweight yet, so we need to teach it how. For that, we add a new method to the factory, createParagraph. A paragraph is always a new instance. When we're working with an unshared concrete flyweight, we're always working with new instances. We are not sharing state in this case. So our createParagraph method accepts a location and a list of characters and simply news up the unshared concrete flyweight, the paragraph, and returns it. Then let's use this. We first create an unshared concrete flyweight. We do that by calling into createParagraph, passing through a list of characters and the location for the flyweight. The warning here means that character object might be null. If we don't want to allow that, we can add a null check, but for demo purposes this isn't required. It doesn't have anything to do with the pattern implementation as such. And then we call draw on the paragraph. As you notice, for the client working with a flyweight or an unshared flyweight, it's completely transparent. What's returned from createParagraph is an iCharacter, which is the same interface as is returned from the call into getCharacter. So as far as the client is concerned, these can be treated in a likewise manner. Let's build and run this. And there we go. We see that we are drawing a paragraph which results in drawing of the first character, as that's the character object we passed through. Let's have a look at the different use cases for this pattern. The use cases for this pattern match the reasoning you'd use in the first place to decide on whether the case is a good match for this pattern. We already looked into that when we described the pattern. Let's recap that. 1. The application uses a large number of objects. 2. Storage costs are high because of the large amount of objects. 3. Most of the object state can be made extrinsic. 4. If you remove extrinsic state, a large group of objects can be replaced by relatively few shared objects. And 5. The application does not require object identity. If these 5 rules check out, then you've got a good use case. So, a library system might be a good use case. A product categorization system might be a good use case. But they are not good use cases by default. Always check your specific requirements against these 5 rules. Let's check out the pattern consequences. A positive consequence is that you may save lots of memory when you use this pattern for an applicable use case. That being said, it might be that you end up with some more processing costs because of the need to inject or compute extrinsic state if that state was stored as intrinsic state previously. That's a disadvantage, but that's almost always offsetted by the reduced storage costs, i.e. the reduced memory use. Another disadvantage is that this is quite a complex pattern, which means that your codebase as a whole will become a lot more complicated. Let's check out the related patterns. The first related pattern is the state pattern. When you implement it without instance variables in the state objects, you're essentially making these state objects shareable, which makes them flyweights. The second related pattern is the strategy pattern. A strategy can also be implemented as a flyweight. And with that, it's time for the module summary. The flyweight pattern is a pattern that uses sharing to support large numbers of fine-grained objects efficiently. Two key concepts related to the pattern are intrinsic and extrinsic state. The intrinsic state can be described as state data that is independent of the context. In other words, it is data that does not change if the object is used in different contexts. Extrinsic state, then, is data that does vary with context. So, different class instances might have different extrinsic state data which cannot be shared. The intrinsic state is thus reused in a way, while the extrinsic state varies. We implemented an example using reusable character objects in a document. Afterwards, we looked at a variation, working with an unshared concrete flyweight. In other words, one that doesn't have state to share. We added the notion of a paragraph to our document example to illustrate this. And with that, we covered all the structural patterns. Time for the next category, behavioral patterns. We'll start with arguably the most commonly used design pattern of them all, the template method pattern.